Next, let's repair a high-frequency smart charger. It's for charging a 72V battery with a no-load output of 86. 2V. What's the issue with this charger? A user said it didn't work after sitting unused for a long time. When powered on, there was no response. The user opened it but found no obvious issues. The screws here weren't tightened. Let's take out the internal board and examine it to find the root cause. We've opened the charger's board. Look, there's a lot of dust here. It's all over the place. There are even insect eggs and other debris here. Look at the back. You can see more insect eggs. Could these things be causing a short circuit? Let's remove this debris and clean up all this dust. Now let's look at the front side. There's quite a bit of dust in this gap too. Let's start with this. Since it doesn't respond when powered on, we'll first test this fuse to see if it's blown or intact. Flip the board over and test the fuse directly. Look, the fuse is blown, which indicates a short circuit. Let's test the bridge rectifier output. See, it's a direct short. Let's test this component too. It's also shorted. Everything's shorted. Now, about this charger's structure, it's an LLC design. Here's an auxiliary power supply and 2 slanted capacitors. It has 2 main power MOSFETs, main ripple capacitors, and 2 NTC thermistors. This is the output ripple capacitor. The secondary rectifier is blocked by this transformer. The heatsink is here. This is the output control IC. And here's a microcontroller. Okay, so we found it has a short circuit. We don't know if it's the auxiliary chip that's shorted, or the 2 main MOSFETs, or possibly this bridge rectifier, right? Why is the auxiliary power also shorted? Let's measure it. See, the auxiliary chip has an integrated MOSFET which is also shorted. To distinguish, let's remove this heatsink. These components, the MOSFETs and the bridge rectifier, let's remove them. First, remove these 2 screws holding it in place. When removing this component, first add some solder to the original pins. Reflow the original solder, otherwise it'll be hard to remove. Then use a solder sucker to remove it. See, it comes right off. For a good solder sucker, buy this large blue one from our store. The heatsink and components are removed. Look, it's full of insect nests. These are all insect eggs. Let's clean all of this up. Wow, under the transformer too. It's also under there. The transformer fan is also covered. Let's remove the transformer. This has turned into a garbage cleaning job for our viewer. The transformer is removed. Look, there's even a huge bug here. What a mess this repair has turned into. Over here, Fusion has some too. It's ready now. Let's test the rectifier. Front switches and rear rectifier. Check for issues. Test these two switches first. Yes. This is urgent. What about the back? The rear rectifier is fine. Let's test the bridge output. It's normal now. Test the rectifier bridge directly. 0.49, no problem. 0.49, no problem. Main power switches are out. Now let's test auxiliary power. Auxiliary power was short-circuited earlier. Now check if it's still short-circuited. Auxiliary power is normal now. Auxiliary power tubes are working, guys. If we install a bridge, the light should come on. But we're not doing that now. Let's remove these capacitors and check the drive circuit. Main switch is burned, so let's check the drive circuit. After removing capacitors, let's clean this area. Now let's test these components here. Examine the drive circuit carefully. I'll do a quick measurement. I'll report if I find any issues. If it's fine, I'll move on. No significant damage found on the drive circuit. Next, let's check these two optocouplers. We'll use this component tester. Test this optocoupler. It's for 220V detection. Both red lights flash. This optocoupler is fine. Now test the auxiliary power feedback optocoupler. Both red lights flash. This one's fine too. All right, let's look for the replacement tube. If we have one, we'll replace it. Found two tubes. Let's remove the old ones first. Reconnect these two capacitors. Now, reinstall the voltage regulator. Install the 3 RPR tube here. Remove the original fuse. It's a 10A fuse, see the size. Solder the new connections. Replace with a new fuse. We've replaced all damaged components on this charger. Now let's connect the 220V input. Let's power it up and check the indicator light. Ready, 3, 2, 1, power on. Look, the light's on. Auxiliary power is working. Next, let's check the capacitor voltage. Okay, flip the board over. Measure the voltage directly.